will explain a little bit about what is a normal distribution, and what we can say that I will explain about the introduction of the normal distribution. Okay, let's move on to the introduction, which is what is normal distribution. When we heard about the normal distribution, we need to imagine about this type of graph, which is bell-shaped curve. This type of bell-shaped curve is the total area of this bell-shaped curve is equal to 1, which is this area will equal to 0.5, and also this area will equal to 0.5. And the normal distribution are symmetrical with a single center peak at the mean of the data. Okay, as you can see at the center, we have a mean. Okay, now we move on to this type of explain a little bit about the explanation. A normal variable with mu equal to 0, which is we can see as here we will have a mu at the center, and the variance standard deviation equal to 1, which is this total area of the normal distributions. Okay, a standard normal random variable is denoted as z. Okay, this is our main formula, which is z equal to x minus mu divided by standard deviations and variance. I'm sorry. Okay, suppose x is a normal random variable with mean with this and variance this, then we can conclude that the normal distribution with these equations, which is where the z is standard normal variance, this z, the capital letter z, and the lowercase z is equal to x minus mu over variance with is the z value obtained by standardizing x. Okay, the probability is obtained from the z tables. You can see further with the example. Okay, all the area from the z table given to you are to the left of the value of z. Okay, which is all the value will given to you with the left, which is this area. Okay, if you want to find this value, you need to 1 minus with this value. Okay, that's all from me, and let's look at to the questions.
I will explain the example for the normal distribution. So this is the questions that I want to do the example. So as reported in Runner's World magazine, the times of the finishes of the new city 10-kilometer run normally distributed mean 61 minutes and standard deviation 9 minutes. So from this question, we can get the value of the mean, which is 61, and standard deviation with 9. So the question is to determine the percentage of the finishes with the times between 50 and 70 minutes. So basically, the normal distribution function is, so in the middle is the mean, which is 61, and from this question, which is 50 and 70 minutes, in between this 70 and 50. So we need to find this area. Okay, so we need to find the z1, which is the formula is x minus mean over standard deviations. So our x is 50 minus by mean 61 divided by 9. So we get the answer is negative 1.22. So we find the second z, which is z2, is equal to 70 minus 61 divided by 9, and this is equal to 1. So, okay, for this 1 and -2, we need -1.22. We find using the Z table. So we get the value for Z distribution, which is 0.3888 and 0.3413. So to find all the distribution, we just plus is equal to 0.3888 plus with 0.343. So it will be equal to 0.71. So in percentage, we get the value is 73.01%. We need to find the percentage less than 17. So for B, X is less than 75. So we use the same formula, which is we find the Z first. X minus mu mean equal to standard deviation. 75 minus 61 divided by 9. So we will get the it will get 1.5556. So basically the standard deviation graph is like this. So we need to find this 75. We need to find all this area. So this value we find on the Z table. So we get the Z is equal to 0.4406. 0.4406 means just in here. So this total of this Z ini is 0.5. So we need to plus 0.4406 plus 0.5. So we will get 0.9406. So the percentage is 94.06%. So this is the questions.
Hi, okay, let's go through to the second question. It's about batteries. Okay, let's look through the question. Okay, the question is about the lifetime of batteries in a curtain application are normally distributed with mean 50 hours and standard deviation is 5 hours. So we need to find the probability that a randomly chosen battery lasts between 42 and 52 hours. Okay. Okay, this is a figure that will show the lifetime of the battery, which is the mean nu is 50 hours and the standard deviation for this battery life is 5 hours. So the X represent for last 42 and 52 hours. So we need to find the population between 42 less than X and less than 52. Okay. Okay, let me see the solution of this question. Which is, we know that the formula for normal distribution is Z equal to X minus mu over sigma. And for this question, we have two Z, which is Z1 and Z2. X minus mu over sigma. For Z1, 42 minus 50 divided by sigma, which is negative 1.60. And for the Z2, 52 minus 15 over 5. Sorry, this is 5 equal to 0.40. So this is where the Z for Z1 and this is Z for Z2. Which is the lifetime is 42 hours and 52 hours. So let me go through the normal distribution and Z distribution, which is the 42 is here, which is the mean is here 15 and lifetime between 42 and 52. So we need to find the area in a blank space. Use blank space. And next we after that we find the Z value from the Z table, which is when the value is negative 1.6, the value from Z table is 0.0448. Then for Z is 0.4, the value from Z table is 0.6554. So if we need to find the probability of the battery that a lifetime between 42 and 52 hours which is we need to divide the Z table value, and the probability is this.
Hi, okay, so I will explain about the last question. So, okay, this one is the last question. So, for the question is about Molly earned a score of 940 on a national achievement test. The mean test score, this one. Okay, this one, Molly earned a score of 940 achievement test, which means this is the value of X, and then the mean test score was 850 with a standard deviation of hundreds. So this is a mean value, and this is the standard deviation value, which is 100. So what is the proportion of students had a higher score than Molly? Okay, so for this question, firstly, we insert the formula of Z, which is Z is equal to X minus mu, which is mean, over standard deviation. So firstly, there is two graph, which is a normal distribution graph and Z graph. So okay, this one is the normal distribution graph, which is the center is the value of mean, and this is the value of X. Okay, so for this one, this is normal. Okay, so for this one, we insert the value of X, which is 940, and the value of mean is 850 over standard deviation 100. So the value is 0.90. So this is the value of Z. Okay, so now I will show you the Z distribution graph. So for this one, which is the question that is a student had a higher score than a Molly. So this one is 0.9. So it means we have to find this area. Okay, so from the Z distribution graph, we can see that P Z less than 0.90 in the graph is 0.8156. So which means this is a greater, which is despite, less, which is despite. And now we want to find the greater than 0.90. So we this greater than 0.90. So the overall of this area is 1. So 1 minus 0.8159. So we get 0.8141. So yeah. So this is the answer. Okay. So okay, that's all. Okay. So that's all from us. Bye.